Hey everybody. So I was going through some old videos on the computer tonight, and I came across some video clips back from May 2020, and it was of a power outage that we had, and this one was kind of interesting. So of course this video will have to do with power distribution and all that good stuff, but for those of you who are interested in computers and stuff, hang tight because this relates to you too. So this power outage that we had, it was on an unseasonably cold night in May. We had temperatures that were in the mid-30s, which was extremely rare for this area in middle to late May. I actually had a fire going in the wood stove. But late at night, the lights blinked out, came back on, blinked out, came back on, and then stayed out. So it was actually a power outage, and of course there was no wind, no nothing like that. And of course, yes, it was kind of cold, but it wasn't atypical for this area. Like it was what you normally would have in this area, let's say on a night in January or February, kind of like right now. The thing is though, the outage was kind of a weird one. So we was out of power for probably about 2 or 3 hours, and I spotted line crews inspecting the power lines trying to find the issue. Either they found the issue and they were just inspecting the whole line, or they were seriously unsure what the problem was and they were patrolling the whole line. So they were patrolling this single phase line that feeds their neighborhood, and they always do that when there's an outage that affects the main line because, well, this line's on a recloser, so they always check it just in case, let's say in rare case the recloser was to fail. But a couple hours later the power came back on, and first thing I noticed, my wood stove, which is going right now, you can barely hear it because I've done a fan mod to it, but the stock blower on my wood stove was very loud, and it was very sensitive to line voltage. And I noticed that when the power came back on, it was racing pretty fast. I'm like, this ain't right. So I grabbed my multimeter and I checked the voltage at an outlet, and I was getting 130 volts, which is high. It's out of spec for North American voltage, 120/240 volt service. Generally, I think the highest you really want to have is like 126, 125, 126. Generally, our electric utility kind of goes for 125, and the reason for that is because at the substation, you want to be sort of on the high end. That way, when you get many miles down the line, customers down the line will still have, like, let's say 121, 122, or 120. So again, 130 volts is rather high. It's not good. Some sensitive electronic devices could get damaged for that, and think of this. Was getting 130 volts on a 120 volt circuit. That meant we were probably getting 260, 265, maybe even 270 volts on 240 volt circuits, which is not good. Matter of fact, there were some reports of people's heat and air systems getting damaged from this when the power came back on. So when the power company tells you that it's important to turn off unnecessary devices during an outage, that way when power is restored, it's for a couple of different reasons. Number one, they want to reduce demand on the system whenever the power comes back on. When they close that line back in, especially if it's been out for hours, especially on a cold night, there's going to be a huge amount of demand because everybody's water heater is going to kick on electric. Everybody's heat pumps are going to kick on and then bring on the auxiliary heat, which is a big power user. So there's going to be a lot of demand when that line gets closed back in. So they want you to shed load. But another reason is they want you to shed unnecessary devices that could get damaged, let's say from power surge. And this is why it's important for my computer tech audience. It's why it's important to have decent quality power supplies in your computers. And of course the Mid-Tower Deluxe didn't have any issue. The Q-Cure Plexi, no problem. Didn't have any issues with those two systems when the power was restored. But my TV box system, not the slim one, but the TV box I used to have, and I'll put a card in the upper right corner to show you which one I'm talking about. That system had a pretty cheap end power supply in it, and it was affected by that restoration. When power was restored, it actually damaged that unit because I think one of the rails in it was starting to get out of spec, and it caused damage to a solid-state drive in the computer. So it's important to have a good quality power supply unit in your system. Okay, so you're wondering what the cause of the outage was. Well, the thing is, when the power came back on, we were getting 130 volts, which led me to believe that it was possibly a failed voltage regulator at the substation. So the substation that feeds this area has regulators on every circuit out of the substation, every three-phase circuit out of the substation, and this particular sub has I think 7 circuits out of it. So the regulators are actually beyond the reclosers in the substation for each circuit, so when the regulator shorted, it tripped the recloser out to lockout, and that would explain why we lost power. So when the power came back on, it was 130 volts, and I'm going to show you the footage here so that we can see for yourself. Okay, so our power came back on, and here's something rather interesting. You hear my wood stove fan. Listen to it. It's screaming. So I decided, okay, let's check the line voltage. Okay, so I checked the line voltage, and I just go in here because this outlet's easy to probe. So I measure our line voltage. We're getting 129 volts, which is high. It's definitely high for this, at least for what I'm used to here. Normally it's about usually 120 to 125. Yeah, we actually hit 130. And I should mention this right now, the power just came back on, so the demand is higher. You know, everybody's like, for example, houses like mine that are all electric, you know, we have hot water heaters. Some of us have heat pumps or electric heat. That's all running right now. It's cold outside. Everybody's houses are trying to warm back up. Everybody's water heaters kicking back on. There's more demand right now. So this is rather bizarre. It's like it's almost like the step regulators in the substation are pushing a little too high. Really bizarre. Okay, it's a couple minutes later now, and I was sitting at the computer here, and I noticed the wood stove fan calmed down just a little bit. So, go back in here, we'll measure the voltage again. And we should be getting about 124. Or 125. So yeah, pretty crazy stuff. So I did confirm with a lineman with the utility that it was in fact a failed regulator that got replaced. And when this new regulator was put in, it was a little bit out of tolerance, and they had to get it back into spec, which only took them about a couple minutes or so, but that was still a couple minutes of having voltage that was out of spec and enough to possibly damage some things. So regulators, they perform an essential function. So they're typically found in substations and are also sometimes found out on the distribution feeder many miles away from the substation. So as demand on the system changes, for example, like during the morning, on a cold like winter morning, there's going to be a lot of demand because you're going to have heat running and stuff like that. And of course everybody's cooking breakfast, getting ready for work or school. And then during, let's say, the afternoon, things calm down, and then later in the evening everybody's cooking their supper, so that demand goes up and down. And as the demand goes up, the voltage will tend to sag, and those regulators will step up to bring that voltage back up where it needs to be. And when that load gets shed off the line, well, the voltage will only go up, and then the regulators have to step it back down. So they perform that essential function in the substation, and also many miles down the road from the substation, you may have issues where the voltage is low because of a long line with a lot of load on it. So they'll put regulators out on that line many miles away from the substation to correct voltage issues. So to wrap up this video, it is important that when your electrical utility tells you to unplug unnecessary appliances during a power outage, it's to help lower demand when power is restored, but also it's to help prevent stuff from getting damaged due to, let's say, out of tolerance voltage. For example, if a regulator goes bad and gets replaced. Sometimes it can happen. So anyways, that's it for this video. Hope you enjoyed it. Thanks for watching. Hey everybody, thanks for watching this video from QCreator channel. If this is your first time, please subscribe to the channel and tick the bell so you get notified of a new video I post. Please like this video if you enjoyed it, leave a comment, and share this video as well as the channel with your friends to get the word out. In addition, I have a second YouTube channel, that's QCompMTDX. Again, I hope you enjoyed this video, and thank you so much for your support.